Why, hello there. Thanks for watching this video about a rational equation, but we're going to try to figure out the inequality. So we want to know, find the interval or intervals for which this rational equation, 2x plus 4 divided by x minus 2, is greater than 0. So what that means graphically is when is this graph above the x-axis. So in order to do this properly, we have to know a lot about graphing of rational equations. So there are four main concepts that we need to figure out. First of all, the vertical asymptote. Okay, the vertical asymptote comes from your denominator. We want to know when will x minus 2 be equal to 0. So that occurs when x equals positive 2. So we have a vertical asymptote through positive 2 on your x-axis. Okay, the next thing we want to do is figure out your horizontal asymptote. Okay, taking a look at this graph here, this equation, we notice that we have a 2x on top and an x on bottom, which means this is neutrally a neutral linear equation. It means it has a linear equation on top and a linear equation on bottom. So in order to figure out the horizontal asymptotes, we look to the coefficients. So we have a 2 on top and a 1 on bottom, means we have a y equals 2 horizontal asymptote. So we make our dashed line through positive 2, and that's your horizontal asymptote. So the next thing we look for is your y-intercept. Where does this thing cross your y-axis? Now to do that, we need to plug in 0 everywhere we see an x. So you have 2 times 0, which is 0, and 0 minus 2. So we have what's left over is a 4 over negative 2. So we have a y-intercept at 0, comma, negative 2. So it crosses your y-axis here. And last thing we want to do is figure out what your x-intercept is. I don't know if you'll be able to see yellow. No, yep, no yellow. Let's just do black again. To find the x-intercept, we need to solve the numerator. So 2x plus 4 equals 0. So x will be negative 2. So it crosses your x-axis at negative 2. Wow, lots of 2's in this problem. Okay, so the graph, therefore, is going to cross through those points as well as hug our asymptote. So it's going to come up here next to the horizontal, cross through our 2 points, and then hug your vertical asymptote. And because of symmetry, it will be up here in this other alternate quadrant, okay, with the same kind of distance away from the 2 asymptotes. So now we can answer our question. When is this graph above the x-axis? Okay, so we notice that, of course, the graph is above the x-axis everywhere to the right of our asymptote. Okay, all this stuff. Anytime we have an x here, your y values are above your asymptote. In addition, we have all this stuff. Everywhere up here, our graph is also above the x-axis. So let's see if I can change the color. How about red for our intervals? That's a good size. So we have from negative infinity all the way to negative 2. Okay, from negative infinity to the x-intercept, the graph is above the x-axis. And everywhere from this vertical asymptote off to infinity, our graph is above the x-axis. That is where 2x plus 4 divided by x minus 2 is larger than 0. Thanks for watching.